This question asks which group has the highest priority according to the Kahn-Ingold-Prelog rules. So this question is actually a pretty straightforward question. We just have to remember basically what's that first rule of the Kahn-Ingold-Prelog rules. And the number one rule of the CIP rules is that you're going to use the atomic number to distinguish between groups that are attached to chiral centers or pi bonds when you're doing E versus Z. So in each of these cases, what we want to focus on is what atom is attached in each case. All right, so in this case, we have 3 carbons, an oxygen, and a fluorine. So we just need to decide which atom has the highest atomic number. If we think about the second row of our periodic table, the atomic number increases as we go to the right. And so fluorine is going to have the highest atomic number right here. And it's going to beat out all of the other options. Okay, even though when you think about the carboxylic acid, you think, okay, it's got 3 oxygens attached to it. The fluorine still beats it out because the fluorine is going to have the highest atomic number. If we also wanted to think about perhaps ranking these by CIP rules, we could also do that. So if we wanted to rank them, we already know that the fluorine is going to have the highest atomic number. And that's going to be followed then by the one where the oxygen is directly attached. The ones that have carbons are a little bit harder to do, but we can still think them through. The reason why they're a little bit harder is because they all have that tie at the first layer where there's a carbon directly attached to our chiral center or our stereo center. In order to determine how the tie gets broken, you draw out what each is attached to at the second layer. So the carboxylic acid, we would say, has 3 oxygens attached. The ethyl group has a carbon and 2 hydrogens. And then the group that has the alcohol on the end would be an oxygen and 2 hydrogens. So at the first layer, we can distinguish between answer choices B and C. B has an oxygen and C has a carbon. So the one that has the oxygens are going to be higher automatically. So we can also say that A is going to have a higher priority than C. So C is our lowest priority group. To distinguish between A and B, we have to look at the second layer. And the carboxylic acid is going to have a higher priority than the CH2OH group. So this will be our 3 priority, and this would be our 4 priority if we were ranking these 5 molecules by priority.